Good day, everyone. My name is Cheryl B. Luga, and this video presentation is all about logarithmic function. The content of this video presentation are as follows. Number one, the definition of logarithmic function. Number two, converting and solving logarithmic functions. And number three, the properties of logarithmic function and its graph. Logarithmic functions are very much essential to every sphere of human life, especially in solving exponential equations. Some examples of this include sound, or the decibel measure, earthquakes, the Richter scale, and chemistry, pH balance, a measure of acidity and alkalinity. By definition, the basic logarithmic function is of this form, where a should be greater than 0. It is the inverse of exponential function a raised to y is equal to x. The equation of the logarithmic function is read as f of x is the logarithm of x to the base a, or y is the logarithm of x to the base a. Take note that in the notation, a is the base, x is the power, and f of x or y is the exponent to which a is raised in order to obtain x. Logarithmic functions include natural logarithm or common logarithm. Here are some examples of logarithmic functions. Natural logarithms. Natural logarithms are logarithms to the base e, or approximately 2.71828, and are denoted by ln. In other words, the natural logarithm of x is another way of writing the logarithm of x to the base e. And common logarithms are logarithms with base 10. The logarithm of x is a short notation for the logarithm of x to the base 10. Here are three examples. The logarithm of 10 to the base 10 is equivalent to logarithm of 10 is equal to 1, because 10 raised to 1 is equal to 10. Then the logarithm of 100 to the base 10 can be rewritten as the logarithm of 100 is equal to 2, because 10 raised to 2 is equal to 100. And the last one, the last example, we have the logarithm of 1000 to the base 10 is equivalent or can be rewritten as the logarithm of 1000 is equal to 3, because 10 raised to 3 is equal to 1000. Now, how do we convert exponential form to its equivalent logarithmic form and vice versa? Some of the non-integral exponent values can be calculated easily with the use of logarithmic functions. Finding the value of x in the exponential expressions, 2 raised to x is equal to 8 and 2 raised to x is equal to 16 is easy. But finding the value of x in 2 raised to x is equal to 10 is difficult. Here, we can use the log functions to transform 2 raised to 10 raised to x is equal to 10 into logarithmic form as the logarithm of 10 to the base 2 is equal to x, and then find the value of x. The logarithm counts the number of occurrences of the base in repeated multiples. Here are some examples and its solutions. Converting exponential form to logarithmic form. When you convert an exponential to log form, take note that the exponent in the exponential becomes what the log is equal to. Example number 1, 16 is equal to 4 raised to 2. Let's identify first the base, the power, and the exponent. The base here is 4, our power is 16, our exponent is 2. Converting this one into its equivalent logarithmic form, it will become the logarithm of 16 to the base 4 is equal to 2. The second example, we have 2 raised to negative 3 is equal to 1 over 8. Identifying the base, power, and exponent, we have our base is 2, our exponent is negative 3, and our power is 1 over 8. It will become the logarithm of 1 over 8 to the base 2 is equal to negative 3. Now let's do the conversion from logarithmic form to its equivalent exponential form. Example, the logarithm of a to the base 2 is equal to 3. Identifying the base, the power, and the exponent of the logarithmic form, we have the base is 2, the power is 8, and the exponent is 3. Converting this one into its equivalent exponential form following the format x is equal to a raised to y, it will become 8 is equal to 2 raised to 3. Now let's try to solve and find the value of x in the given logarithmic equation. Number 1, the logarithm of x to the base 5 is equal to 4. Converting this one into its equivalent exponential form, we can solve the value of x. So the logarithm of x to the base 5 is equal to 4 can be changed into x is equal to 5 raised to 4. 5 raised to 4 is equivalent to 625. So the value of x is 625. Now here are some properties of logarithmic function. Number 1, the product property. Number 2, the quotient property. And the third one is power property. Product property states that the logarithm of m times n with base to the base a is equivalent to the logarithm of m to the base a plus the logarithm of n to the base a. Now for the quotient property, it states that the logarithm of n divided by n to the base a is equivalent to the logarithm of m to the base a minus the logarithm of n to the base a. And for the power property, the logarithm of x raised to n to the base a is equivalent to n logarithm of x to the base a. Now let's use these properties to solve logarithmic equations. We can solve this given problem using the properties of logarithm. Given is the logarithm of x to the base 2 plus the logarithm of the quantity of x minus 6 to the base 2 is equal to 4. Now applying the product property, the logarithm of x to the base 2 plus the logarithm of the quantity of x minus 6 to the base 2 will become the logarithm of x times the quantity of x minus 6 to the base 2 is equal to 4. Now, changing this one into its equivalent exponential form, this will become x times the quantity of x minus 6 is equal to 2 raised to 4. Applying the distributive property, x times the quantity of x minus 6 will become x squared minus 6x, and 2 raised to 4 is equal to 16. Now subtract 16 to both sides. This will become x squared minus 6x minus 16 is equal to 0. And factoring x squared minus 6x minus 16, the factors are the quantity of x minus 8 times the quantity of x plus 2 is equal to 0. The values of x now for this given logarithmic equation are x is equal to 8 and a negative 2. Now, these are the graph of the exponential function and logarithmic function. Now, what are the properties of the graph of a logarithmic function? Here are the four properties of the graph of logarithmic function. Number one, A should be greater than 0 and A should not be equal to 1. The second property is that the logarithmic graph increases when A is greater than 1 and decreases when A is greater than 0 and A is less than 1. The domain of the logarithmic function is obtained by setting the argument of the function greater than 0, and the range is the set of all real numbers. That ends my presentation. Thank you so much for watching.